observe the motion of an electric train. You find the train picks up high speed even before leaving the platform. The train travels at constant high speed until it approaches the next station. There is a sudden drop in speed when it enters the station till it finally stops. The first and the last part of this train's motion has high positive acceleration and very high negative acceleration or retardation. Acceleration of a body is the rate of change of its velocity with time. The average acceleration A dash is defined as the change of velocity divided by time. V2 and V1 are instantaneous velocities at times t2 and t1. The SI unit of acceleration is meter per second square. On the VT graph, the average acceleration is represented by the slope of the line joining the points V1, T1 and V2, T2. Just as we defined instantaneous velocity, we can similarly define instantaneous acceleration. On the VT graph, instantaneous acceleration at any point on the curve is represented by the slope of the tangent drawn at that point. Like velocity, acceleration is also a vector with both magnitude and direction. The acceleration of a body can change with either a change in the magnitude of its velocity or change in the direction of its velocity, or both. In rectilinear motion, we have only two directions of motion: positive and negative. Therefore, we have two types of velocities, positive and negative. Similarly, we have two types of acceleration, positive and negative. Formulating a proper and consistent sign convention for acceleration is very important. Let's understand what constitutes positive and negative acceleration. Zero acceleration stands for uniform velocity. That is, the velocity does not change with time. Let us consider cases where acceleration is positive. Case 1. Let us consider a body, say, a car moving along a straight line. That is, from point A to B, with increasing magnitude of velocity. The body is said to be moving in the positive direction. Here, delta V is positive and direction of motion is positive. Therefore, with these two values being positive, acceleration is also positive. Case 2. In this case, the car is moving in a negative direction. That is, from point B to A, with a decrease in the magnitude of velocity. Here, delta V is negative and the direction of motion is also negative. Since the product of two negative values is positive, acceleration in this case is also positive. Let us now consider cases where acceleration is negative. Case 1. Now consider the car moving in a positive direction. That is, from A to B, with a decrease in the magnitude of velocity. Here, delta V is negative and direction of motion is positive. Since the product of a negative and a positive value is negative, the acceleration in this case is negative. Case 2. In this case, the car is moving in a negative direction. That is, from B to A, with an increase in the magnitude of velocity. Here, delta V is positive and direction of motion is negative. Since the product of a positive and a negative value is negative, the acceleration in this case is also negative. To decide whether acceleration is positive or negative, the terms retardation or deceleration are confusing while solving problems. Here is an easy way to get the sign convention for acceleration right. In the 4 cases we have just studied with respect to points A and B between which the body traverses, let us fix the velocities of the body at these points as v at A and v dash at B. The 4 cases are tabulated. If the origin and direction of motion are discarded, we are left with the type of acceleration and the relation between the velocities at 2 points. If v and v dash are taken as the initial and final velocities in any given problem, then if v is less than v dash, then acceleration is positive, else negative. Let us see what the xt graphs for positive, negative and zero acceleration look like. The xt graph for motion with positive acceleration curves upward. For negative acceleration, it curves downward. For zero acceleration, it is an inclined line. Let us see what the VT graphs for all 4 cases explained earlier look like. Body with positive acceleration, that is, positive direction and positive velocity. The graph is an inclined line above the x-axis with upward inclination. Body with positive acceleration, that is, negative direction and negative velocity. The graph is an inclined line below the x-axis with upward inclination. Body with negative acceleration, that is, positive direction and negative velocity. The graph is an inclined line above the x-axis with downward inclination. Body with negative acceleration, that is, negative direction and positive velocity. The graph is an inclined line below the x-axis with downward inclination.